Hello and welcome to today's lecture. Today we're looking at the starter resistor starting method, of which a resistor starter is actually a device for slip ring induction motors, of which it uses external resistors that are connected in the circuit. The reason is actually to increase the starting torque and also limit the starting current. And so at an instant, or meaning at a startup, the high resistance that is actually connected in our system will actually produce high starting current, or starting torque rather, at low speed with limiting current. And so as the motor accelerates, meaning as the motor increases speed, we actually be able to cut off this resistance. And once this resistance is cut off, you realize that the motor will be connected to the full voltage, of which at this point, meaning we actually completely bypass the slip rings where we are short circuiting them. And so as you can see on the left side, that is our stator and our rotor that is connected with the slip rings and also with the starter as aforementioned above. Okay, and so the operation is that the full supply voltage is applied directly to the stator windings, of which external resistance is inserted in series with each phase. Since this will also help us also to reduce, and also the rotor circuit through the slip rings and also the brushes, right? So the high resistance in the rotor limits the starting current while simultaneously increasing the starting torque, of which as the motor speed increases, the external resistance is progressively reduced, like I had mentioned, and so automatically or manually this can be done. And the motor, once it reaches this rated speed, like I earlier said, we expect these resistance to be completely cut off. And the purpose is that the primary function is to enable the motor to start under heavy loads, all right, by increasing the rotor resistance. The high inrush current typical of direct line start is significantly reduced. And so this will actually provide a smooth and controlled start for applications that require preventing mechanical shocks or damage to the driven equipment. And the applications is that the rotor resistance are commonly used for high inertial loads, high loaded belt conveyors, where high starting torque is required at a full speed range, like I had mentioned. And so a simple diagram or circuit we can use is actually this one, where we are saying we press our start push button here, then our contactor M is going to energize. Once our contactor M is energized, then we have this M also closing. Once it closes, our timer is energized. So meaning these are going to energize at the same time. And after a preset time, that is when R is actually going to energize. So as it is here, M, once it is energized, all right, after a preset time, then R energizes. So meaning since current will always find an easy path, and so it will pass here from M down to R that is closed, then the overload, and the motor is actually connected to a full load. And so in this method, we add resistors that will actually help us in the reduction of a starting of our motor. And that's by adding resistor, we can be able to control the supply voltage. So only a fraction of the voltage of the supply is applied at the time, yeah, of the starting of the induction motor. And so the resistor start will consist of 3 resistors, since we are saying for each phase, and the starting current is kept at the minimum in this type of starter. Okay, the advantages are that they are suitable for use in speed control applications, and they have extremely flexible starting characteristics, and they provide smooth acceleration. Thank you so much.